Indian National Laboratories requested a user-configurable device that will reprogram an analog signal according to various integrated sensors and external digital and analog inputs. The analog signal reprogrammer we are tasked with creating is a prototype for use in a laboratory setting and for eventual design of a more specialized device. The ASR must also be rated for rocket launch and flight environments. Our solution is a PCB with 6 key subsystems: power management and voltage regulation, onboard environmental sensors, device reprogramming control logic, off-board interfacing, analog reprogramming circuit, and device programming and debug.
The reprogramming stage comprises of op-amps controlled by digital potentiometers through SPI. The required bandwidth is 1 GHz and is subject to change. The input signal will be filtered, amplified, and shifted depending on input stimuli such as temperature and humidity. This schematic shows the analog signal reprogramming stages. It shows the order in which the signal will be reprogrammed, starting with the filtering, into the gain, and then finally into the phase shifting stage. This is our demo built onto a solderless breadboard, where we confirm our theory of operation. And here are our demo results. Depending on the other input stimuli as mentioned before, the input signal will be subject to analog signal reprogramming of various degrees.
The microcontroller circuit and hardware is a little more complicated than the analog circuitry. The microcontroller is responsible for interfacing with all onboard devices. The low-level reprogramming and debugging is performed over JTAG. The user interface is accessed over UART and USB. Sensors are on board, but digital and analog inputs are exposed as pin headers for off-board communication. Power management is 30 volts DC input, but voltage regulators are distributed around the board to provide different voltage levels to different components. The analog circuitry is interfaced using digital potentiometers to control analog circuitry from digital circuitry.
The mechanical design portion of this project was centered around the enclosure of the device. The enclosure needed to be strong enough to withstand shipping environments, in addition to electrically isolating the circuit board. The group chose to fabricate the enclosure using 3D printing as it offers both speed and flexibility, which are 2 key factors to consider when prototyping a product.